So that makes it really perfect for cryptocurrency and balance sheets, because that's sort of a simple, self-contained store of numbers. But since Bitcoin, there's also been this development of smart contracts, and that's really allowing people to put software onto the blockchain so that that software can have that same sort of immutable guarantee that we have from a blockchain. So you can put up a program, everyone can sort of know how that program will act, and know that you're not editing the code from day to day, and know that all the inputs and outputs are sort of guaranteed. And so with a smart contract, what a lot of people want to do is say something about the real world. Let's say someone wants to implement a betting contract. So if they did that, let's say they put up a bet like, who thinks Hillary Clinton will win versus who thinks Trump will win. Then let's say that everyone in the network participated in this bet, and they bet, a few dollars one way or the other. And let's say that 60% of people ended up voting for Hillary Clinton, and then Trump ended up winning.
Sorry.
So we have that sort of, let's say we have that situation. And now we need to say, how is the smart contract going to know who actually won? You may think, okay, it can fetch it from the real world somehow and just know that Trump won. But that's not really true. That all has to be done through a computer one way or another. The traditional sort of software idea that people may have is you're going to go fetch that state from the New York Times, something like that. But you run into problems when you're talking about blockchain technology and when you're talking about, millions of dollars in a bet on the line, where, people may not be incentivized to really be honest. So in our situation, a majority of the people on the network are going to lose money if they tell the truth. And only a minority is going to benefit if they actually, reflect the true state of the world. So we need to be able to find someone to tell our smart contract what really happened, in spite of all those, motivations for people to lie. And people could lie in a few different ways. They could, depending on how we implement our smart contract under Oracle, they could either just say that it was, whatever to benefit them, or they could even manipulate certain data streams if we implement it towards, fetching from the New York Times. So if we were to have our Oracle fetch from the New York Times, maybe the person running the Oracle software would actually, put up a fake website on their own internal network so that their computer is fetching from the New York Times when in reality it's fetching from some local website they hosted that's telling an altered version of the data that we're looking for. So that's really why we're talking about data. It can have some high stakes around, not just money, but also the result of certain agreements, the behavior of certain programs as we want them to be. And one of the big strengths of a smart contract is that you can actually have some really strong guarantees when working with real-world data. So a lot of people think of them as just that. Like, it's not just a program, it's actually contracting. It can work as one. Touch ID or Andy password.
Okay. Let's see.
Sorry about that. Try to touch it a bit more for the next few slides. Shouldn't be too bad. Okay.
Yeah, sure.
So here are just some of the use cases I was talking about. Going into sort of betting is really the easiest one, because I can really demonstrate cases where, let's say that you were to have like a democratic vote to try to determine the truth. So you just ask everyone in your network, who won? Was it Trump or Clinton? But when you have cases where, a majority of the people are going to lose money if they tell the truth, then they probably won't want to end up telling the truth. And you need to figure out a way to make a better oracle than just a simple vote to ensure that you can actually get down to the truth no matter what situation. So, in general, a smart contract is more like a program, and a blockchain is more like a data structure. So when I'm talking about
I
use
meant
cases,
blockchain, I'm sorry.
okay. So smart contracts are generally implemented within blockchains.
So when you were describing a blockchain that you cannot update or add, you only can add to the end, I guess I'm confused as to the smart contracts, how they are implemented in the blockchain.
Yeah, so essentially what happens for a smart contract is that within the blockchain technology, how that's implemented is by basically giving every computer participating in this network software that will run a node. And that's, it's using computing power to be a member of this network. The same way that you would get in a, traditional distributed system of, web servers and all that talking to each other. And you're just giving it software to kind of run a network on top of the internet. And you can access that if you listen to certain rules that have been implemented by that software. So that sort of software that gets put onto computers, since Bitcoin, a lot have implemented certain features to allow for smart contracts to be possible. And that's mostly by creating, some sort of programming language, some of which are Turing complete and some of which aren't, which actually let people just write code. It gets implemented into the blockchain, so it gets implemented into that sort of linked list data structure in a way that the computers who run the node of a network are actually sort of running the software as time goes on. So then you're basically getting like a million or just basically lots of copies of that program across a ton of different computers that can't change the code. And so then you basically know, because there's so much redundancy, that no single person is going to be able to change that program without the network knowing.
Okay.
So basically everyone can kind of see 500 people are running this version of the program that got uploaded, and that person's trying to run a different version that gives them $1 million.
Right.
And you know that that version is false.
So that's where the lying you're talking about is impossible to lie.
Yeah.
Gotcha.
And I wouldn't say impossible. Just to go a bit into detail, if you have a majority, then on a lot of systems you can actually, basically lie, and because you have a majority, the computers get tricked into thinking that the lie is the truth. But there are various blockchain projects, and I don't want to go into, cryptocurrency by cryptocurrency and make people think I'm giving investment advice. But, some have actually implemented systems that make it so that you need more like, 80% supermajority in order to be able to use the network. And some of those get rid of other guarantees and other strengths. So it's kind of good to measure and learn about those technologies by yourself instead of just listening to me on, certain project by project basis.
And so every node has a complete copy of all, the complete history is in each node, or just a portion of it?
So this is kind of down to sort of simple code blockchain stuff, but the way that works is you can really think of it as that sort of state structure. You're never having a situation where each additional node on that linked list is going to have all the information, but the data structure as a whole has all the information. And usually what happens, even beginning with Bitcoin, was that they gave each node what's called a Merkle tree, so that you can see whether or not that node is derived from, the proper entirety of that data structure, to make sure that no one's making up a node and just pretending that there's all this, history behind it that's accurate. So you basically can know that each node follows from the data structure that you're thinking of.
But there will be redundancy in such that a single node would never be fully in control of its data, right? There would be redundancy. So if there were a million steps in the chain, and I was one of them, I wanted to mess with it, I couldn't because there would be others that to verify.
Yeah,
Or it would be
basically,
difficult to lie.
at any point that you would go back and change something in that linked list, it would ruin a lot of the things that your own system and other systems are looking for to make sure that it's like valid. And with Bitcoin, for example, they use something called proof of work, which actually means that you have to use tons and tons of computing power to generate a functional, new blockchain. So if you were to change something, halfway back in the blockchain's history, then you would have to use, tons and tons of computing power to even just get it to the same length. And at the point where you can do that, you should just go and mine with Bitcoin instead. So I wanted to go through just an example to sort of demonstrate the importance of oracles. So let's say that we have an insurance plan, something that's commonly suggested for smart contracts, something where you can put the sort of decision on whether or not you get an insurance claim approved into the hands of a program that isn't going to try to cheat you out of money that you deserve from having paid for your insurance plan. So let's say we have smart contract A implementing an insurance plan for someone. It's supposed to cover illness, homicide, accidents, and then, someone who has this is basically relying on the idea that the smart contract will basically say something like, if accident, then pay the plan holder. So, we have that sort of context, and let's say that someone with this plan ends up going and losing an arm. He was in a skiing accident, he got injured. That should really fall under this inclusion of dismemberment that is included in his insurance plan. So let's say he goes to the hospital says that it's an accident, codes it that way for the insurance, in a way that everything should be covered by his plan. But then he goes and tries to claim on his insurance and ends up getting denied. Who knows how he got denied? Maybe they ruled it, inappropriate behavior while skiing, he wasn't taking the right precautions or something. And he ends up just not getting his money and having to deal with a lot of problems. Even though this is on a smart contract, how would this end up happening? Anyone?
If the smart contract got its information from, maybe a different source than the hospital codes?
Yeah, exactly. So if we go back to here when just talking about how the smart contract is working, then we're saying if accident. So accident could just be a binary indicator of whether or not that accident is covered. Let's say that the insurance company is the ones that are providing that sort of data stream about whether or not something happened. They can just choose not to flip that switch if they don't accept the claim. At which point, we're not really getting much from having a smart contract. Even though they're, blockchain enabled, they're doing everything in an immutable way, they're still the ones providing this information. So that makes it so that, even though they're using blockchain, we don't have any of those real guarantees that prompted us to use blockchain or go with an insurance company that's using it. So here's just going into an example of an insurance plan. It uses, all the same terms, except it uses a different smart contract. So smart contract B is implemented with a proper oracle. And the smart contract ends up automatically accepting the claim. So the way that this would look is that the smart contract would say, instead of just if accident, then pay plan holder, would say if the oracle says that this was an accident, then we'll pay the plan holder. In this situation, who has an idea for what the oracle would be? What would it look like? So an Oracle could be implemented a few different ways. It's not a specific person and specific organization or database, but it could be. It could be any one of those. It could be any combination of those or a program relying on some of those for its information. To make this example pretty clear, I'm just going to go ahead and say, like, this could be an Oracle where it is, using hospital computers, so it needs the data needs to come from the hospital, and then we'll pull data from the hospital's database. So in that way, we know that the information can only come from the hospital, and we know that it can only come from their database. So in order for someone to basically lie through this Oracle, they either have to have access to the hospital computers and to the credentials to, alter the hospital's database, which will basically mean like some hospital IT staff, some hospital doctors. And already we've sort of narrowed it down to putting the sort of responsibility from the insurance company, who arguably has reason to be pretty biased, down to someone with a lot more authority into whether or not those claims should be covered. So so now we have a situation where if the doctor says that this should be covered, then it's covered. Obviously, there's some weaknesses to that idea. The doctors could just end up starting to accept every claim.
They could take bribes.
Yeah, they could take bribes. They could just do it for the sake of, hospitals tend to want to try to get money. So, the hospitals may push their doctors to just accept every claim. But, arguably, we start to see how an Oracle can really change the nature of getting data onto the blockchain. Oh, this is the same slide. Yeah. So this is just saying that we're accepting claims automatically as doctors approve it appropriately. So I just want to go a bit more into what an Oracle actually is. Does anyone have any ideas? I've gone over it with some ideas, but how do you think that an Oracle is actually implemented?
So you have to be able to verify where the data is coming from.
Yeah. Any other ideas?
The team of people maintaining these inputs, these sources.
Yeah, a group of people could basically vote on whether or not that's a valid data source. So there are a few different ways to implement this. One of the more traditional approaches, because this is blockchain, is to have every node within a blockchain network say, what is the truth of, this event. So every time something gets, every time you want a source of data, so let's say you have this big contract that is having everyone bet millions of dollars on the outcome of an election, you're going to go and ask the blockchain network, hey, so we have this bet, but we need to figure out who actually won this election. So maybe you pay the blockchain a certain fee, the blockchain goes out and asks everyone, what happened. Everyone will be able to vote maybe by IP or by computer, by how much of the cryptocurrency of the network they have, maybe by computing power. And at the end, you just tally what everyone voted. We've gone over a bit how this sort of democratic approach can have some issues. So generally, there are some more elegant solutions to make sure that people aren't lying, either to penalize them for disagreeing with the truth, or just to make sure that people aren't double voting, things like that. So that's sort of the traditional approach, and there's some others that could arguably work better. So having dedicated hardware that can't be tampered with to go out and get data. So I'm not going to touch upon that too much because there are a lot of different ways to implement an Oracle, but hopefully that gives you some idea of what the environment right now looks like. for the implementation of oracles. And there are a handful of projects that I would say approach making an oracle in a reasonable way. And because it is so important, I would say that it should really be emphasized more. Because I've seen like hundreds of attempts to create insurance plans on blockchain through smart contracts, and I've only seen a handful of like functioning oracle systems. I would say nowhere near perfect, but there are definitely some implementations out there. So here's just one example of what an oracle code could look like. So in our earlier example, let's say that oracle says is defined as if the specific data source says something, then return true. As I mentioned earlier, this is a very simple implementation. This is arguably better than not having an oracle at all, because now you can actually assign that sort of authority to someone. So let's say if you were, betting, you were creating betting contracts on the blockchain, if you have this implemented, you don't have to have everyone participating in your bet trusting you to tell the truth. Now you can go and say I'll go and take the founder of Ethereum, or I'll go get the President of the United States, or the former President, maybe more trusted, and have them tell us the outcome of that election. And so this at the very least is an oracle. I can delegate authority of that data to someone else. But in reality, you probably want to be able to come up with an implementation that not only delegates the authority, but makes sure that you're getting basically ensure that you're getting the truth. And so that could be done a few different ways, like go visit every news website out there on every node, and make sure that, that gets reported to the blockchain. But that can arguably, again, just with like big websites, be manipulated. So there are some sort of advances in hardware that make it so that you can have sort of immutable code with a checksum on a processor that will run, and everyone will know what code it's running. And so that's one approach, but arguably, given enough time, and someone will probably figure out how to manipulate those hardware chips. So it's kind of like an uphill battle that still needs to be done. There's some implementations, but even the existing implementations are still going to be vulnerable given enough time. And this sort of ends up becoming a computer security problem that is a bit beyond my knowledge base, at least. So hopefully the moral of that is, if you're going to ever use an oracle, try to find one of the ones that's implemented well. Try not to implement it yourself unless you're going to spend a lot of time on it. And even then, make sure to update it once in a while. This is just a quote from an academic organization around blockchain research. Really just pointing out the fact that most smart contract systems and most blockchain that implement smart contracts don't really have the sort of sources of real-world data that you need. And so you really need to be able to find and use an oracle that can get you the truth. This is just sort of an outline of the process that you would go through. So there's some world state, let's say the world state of Trump winning. There's the oracle who's going to, observe what that state is and then put it into their system to report that data. And then that data is going to go to the smart contract. Just in general, the oracle, the actor who's an oracle, could really be anyone or anything. So if this were a more computer-heavy system, then the actor who's an oracle could just be the computer of someone who is delegated to fetch that data. So it's not exactly going to be someone going and putting in like jump 1. It may just be someone's computer who's constantly monitoring the website, and it will report what that website says. And then we're basically hoping that that world state gets through every step straight through to like the smart contract. But in a lot of cases, there's a big vulnerability between the Oracle actor and the Oracle report. Now I just want to go more into why should we use an Oracle. I don't actually have as many slides for this, so I wanted to ask you guys if you have any ideas of why we would want to use an Oracle. I've touched upon some with like vetting and when money's at stake, but what do you guys think? Do you guys have any ideas of examples where an Oracle would just be really important to have?
Facebook to prevent any social media where incorrect facts or all these sort of chatbots that spread polarizing information that's incorrect. So fact checking just in any context.
Yeah, definitely. That's also a general blockchain use case. So having that sort of immutable sort of source of news where you know what's getting added, who's adding it, and then adding on top of that an Oracle so that all the information you're seeing is coming from reporters on site, it's coming from police reports or things like that. Yeah, definitely a good one.
This kind of touches on the Oracle, but in essence, couldn't the Oracle be AI?
Yeah, that would definitely be one implementation of it. It depends on what you're sort of looking at, and then it also depends on who's running that AI and how it's sort of implemented. But theoretically, if you could have an independent Oracle, like an independent AI acting as an Oracle, where there's not just Google's computers running the AI, or where there's not just some guy with a computer running his AI and calling that an Oracle, but then you still run into that sort of actor report problem, then you could have a more complex AI system, especially for like an implementation of news on social media, that would go out, try to gauge the reliability of certain sources and compile that into an answer for the Oracle, like an answer as an Oracle for the blockchain. Any other ideas?
I feel like it's a lot easier to implement it if there's like an official sort of like, some official source of truth for something. Like an election, it's like, okay, well, there's like the official government count of electoral votes or something. But in a case like Max was saying about like fake news, it's like, well, there are a lot of different sites that have news and like they don't all know about all of the news and, so it's harder to fact check things like that.
Yeah, I would say that once you talk about news, it really gets into like a step above what people are really doing nowadays, because you're suddenly talking about a lot of data processing that is becoming more and more possible over time. But if you want to maintain that sort of immutability and those blockchain guarantees, then you are talking about a sort of data throughput that is only now getting implemented in more projects. I would say, though, that it's not exactly straightforward to get data from a trusted source. So let's say you're relying on a government website or the New York Times. Those websites are always susceptible to hacking, malicious acting. So let's say there's a reporter who made a bet like $1 million on Clinton winning, and Clinton loses. She's just going to go up on that sort of data stream URL and just put an indicator that Clinton won, so that she can get her $2 million. And even after that, she could just like change it back to Trump, so that she can't really be charged with anything. because that's not against the law. And if she's doing her job, then it's not even really going to get her fired, him or her. So you sort of just run into this issue all around where taking this sort of distributed approach that's typical for blockchain can actually be a lot more powerful. Because then you can say you're not relying on any one source or any one actor, but you're actually relying on a lot of people. And feel free to do your research and find some of the projects working on some different implementations of that. Because some actually do try to come up with elegant sort of voting systems that will disincentivize people from, lying. But even then, there may have been some advancements since I last checked, but even like the best systems right now can only guarantee like validity up to a certain participation rate. So if everyone's participating in, a bet on the election, then I don't know if that's really possible to, no matter what, find the truth right now. Apart from the systems where you're still relying on like that website to be accurate. But if you have, let's say, only 20% of people participating in that bet, then you can basically guarantee that the other 80% are going to tell the truth somehow. So you do have guarantees up to a point with existing Oracle implementations, but not any complete guarantee yet.
I saw something on the internet about a JavaScript figure who I respect a lot who works at a place, I think it's called Poet, po.tt, and that's doing this for like creative works. But it made me think, more so now after listening to you, that it's like, well, when something's subjective, like, this doesn't say that it's right. You can only just gauge if it's accurate for what people say, right? So
Yeah.
when something is subjective, like Ariel was talking about, like, the majority can be wrong, even the vast majority could be wrong.
Yeah.
It just I like how it removes the self-interest part of it, but it doesn't. But how do you sort of like correct in this model for when like oops, is there a mechanism sort of like, oh wow, we just realized we're wrong, or we were operating on false information ourselves, and
So I would say there's sort of two issues there. There's sort of an issue where people may not want to tell the truth and it's not related to their self-interest in a way. And then there's a situation where people may just not know. So let's say you're talking about what is the weather in a specific place. Maybe the approach some people will take is to Google it and then report what they see. More precise people are going to go and Google the, closest possible estimate. They may look at, wind patterns and figure out, which weather measurement station actually has the most accurate answer for that. And they'll report that. Then you have two conflicting answers. One common approach is to give the answer a certain range if it's numeric. And that can sort of tide over some of those. As is like programming certain parameters into an Oracle call. So if you want to accept, varying answers and to what degree. The other approach is like, what if people are just not telling the truth for some reason, even though they're not necessarily financially incentivized? You can think of something like jury nullification. That's a case where people on the jury may completely believe that someone's guilty of the crime they committed, but that's not a just answer. So if you have some case that relies on an oracle, trying to think of a use case, maybe like an insurance claim, then you may have like the network actually, just always accepting that insurance claim if they have any sort of participation in that oracle system, because they believe that everyone should get compensated when they're hurt. And that's not really a sustainable sort of model. So there are issues really relating to any use of technology, and those are some of the limitations of even roughly perfect Oracle. It's also something where you have to gauge whether an Oracle is a good choice or not, with just like any technology. And if you are going to use it, you really need to make sure that, you know, your needs are something that the Oracle can really fulfill. So just really, this is a bit, hopefully, more overview and more sort of use focused. But oracles are kind of the backbone of smart contracts. Are really good to know about because when you hear about blockchain technology, a lot of it is relying on ideas of guarantees that may not actually be maintainable without using an accurate oracle. These are just some numbers really highlighting why this would matter at an immediate sort of basis. So this is not even talking about any of the more complex stuff like, you know, Max's social media example, but really going into detail on like, these are things that are happening now. There is a huge online sports betting industry and online betting industry in general. You know, a lot of people actually will engage with online gambling. This is actually a number from the UK and Australia, but you know, online betting is legal in a few different states, so there are a lot of places. Also, blockchain technology has made it so people can bet even if it's not legal pretty easily. So, you know, I would say this is some sort of estimate on how many people will end up online gambling. It's not, you know, people generally tend to be financially worse off if they end up gambling. And I think online gambling has a certain factor of additional addiction compared to traditional gambling. So there's a lot at stake here if there's additional losses for those people. And also online gambling has also increased rapidly in recent years. So people are relying more and more on technology and more on these sites that may or may not have legitimate odds. And they will, you know, end up losing more as a result, being more addicted as a result, because these companies are really optimizing on what to make the most profit. So if, you know, you just can't determine the, you know, what are fair odds, what are fair results, you know, any dice rolled by an online gambling company is probably going to be slightly rigged again, if not significantly. And at the very least, like a proper oracle will be able to like get you real results for sports betting and some other cases, thereby, you know, having the potential to reduce some of those losses for those like significant portion of our population that does participate in gambling. And that really will start applying more to other use cases like insurance as blockchain-enabled insurance becomes more commonplace. And just around any of the other use cases, again, as was get talked before. So that's the end of it. I think I'm a few minutes over, but hopefully that was interesting. If you guys have any questions, I can answer like maybe one or two now, time permitting. And I'll also stay after this just to answer the questions if anyone has them. So, any questions?
How far off do you think it is for, say, for insurance?
For insurance, there are already implementations. I don't think any really have a reliable Oracle system yet. I know some of them are getting traction. I don't know how many have signed on actual users yet, but I would say it's pretty close. And until they start implementing some better Oracle system, then a lot of the things that they claim to be better because they are using blockchain is not going to be a valid guarantee. Because it's just going to be up to them on how they report that data and how they trigger the smart contract one way or another. Admittedly, you could still get some guarantees around like what is their history in paying out in certain situations. And that sort of creates their case history in a more public way, which is valuable information. it's just valuable in a different way, and it's probably not what they're trying to do. Any other questions? Okay, so, hey, I have some attitudes. So, let's see. Okay, yeah. So this is just some questions around how oracles work. It's good to think about who is your oracle. Like, if you have a situation where it's getting information from an oracle, you want to know how that oracle works, who's ultimately responsible for putting in that information,